In this session, let me introduce network theory. This particular network theory is very basic subject which will interlink all the subjects of our electricals like machines, power systems, power electronics, whatnot. See, basically in our ECE guys, for electronics and communication guys, they will mention network theory in the syllabus. For electricals, they will write electrical circuits. What is the difference? Let us see first. And one thing, we don't have any time limitation here. Happily, let us enjoy the process. And you need not write any class notes or any running notes. If at all, if you have to write anything, I only will tell you to write. Don't write anything. Enjoy the process of learning. Okay, see, if I have, for example, if I have some electrical system, this should be called as circuit only. Okay, because this is having one closure path. If, for example, if I don't have a closure path, if I don't have any closure path, this can be called as network theory. See, for EC guys, without having any closure path also, they can send signals in communications and all. So, they should use network theory only. But for example, in our electrical because our operating frequencies are less and all, so for electrical, we cannot transmit without having any closure path. So, point here is very simple. What is the conclusion? Circuit theory means that at least one closure path should be there. Network theory means that without having any closure path, if any network or any system, electrical system is there, we are going to call that as network. Okay, just leave that aside. Now, why we have to learn network theory? What is the purpose of learning network theory? Maybe is it our purpose is KCL, KVL, mesh, nodal, theorems, transients, two ports, resistance, inductance, capacitance, voltage source, current source. What is the purpose? What is the purpose of this subject? The purpose of this subject is, for example, I have one electrical system. One electrical system is there. Okay, electrical system, because we are electrical engineers. Now in this particular electrical system is there, I want to test this system. I don't know what is there inside. I want to test this system, because if I test this system, if I draw performance characteristics of this, for example, this is going to be voltage. What is voltage, what is current and all, I will do in the next video. See, if I have some voltage, if I have some current, what is the voltage current characteristics? For example, if I have some amount of load, how much will be the voltage? How my system is going to behave? If I want to know, again, same thing we do in our machines also, same thing we do in power systems also, same thing we do in power electronics also. Logic is very simple. This is physically existing electrical system. For this physically existing electrical system, for example, if I supply this much amount of voltage, how much current will flow? If you want to know, there are two ways. What is that? Directly take the electrical system, apply the voltage and measure the current. You will come to know in our machines and all, we call it as a direct loading test. But for example, I cannot do this because, for example, if I have BJT, okay, or FET, analog electronics, for example, in a given single chip, millions of transistors will be there. So the moment millions of transistors are there, I can take one transistor and I can say, I can test this particular transistor. For example, in a transistor, I would like to know how much is the maximum collector current capacity. Okay, so how much is the maximum collector current capacity? In order to know that, what I can do, directly I can take one transistor and directly I can keep on increase the current through the collector. At one point it will break down. So then you will come to know terminal response characteristics of BJT. Okay, so that terminal response characteristics, you can you can inherit the same terminal response characteristics of one transistor to 1 lakh minus 1 transistors. In the sense, if I have 1 lakh transistors, in that I can remove one transistor, I can do all testing, direct loading tests, and these particular results can be supplied, or we can think of remaining all 1 lakh minus 1 transistors are having same terminal response characteristics. That is possible. But for example, if I have flyover, okay, so if I have flyover, we do construct flyovers and all, no, civil engineers actually, not us. For example, if I have flyover, okay, for that flyover, if I want to know how much is the maximum load bearing capacity of the flyover, What can you do? Can you dare to do direct loading test? Because if you do direct loading test, at one point it will break down. But by that time, flyover will vanish, will be damaged. So this particular process is a never-ending process. So if I have only limited physically existing systems, we cannot directly test them. So for example, I have flyover. Okay. So in the flyover case, what I have to do? Somehow I have to mathematically calculate. And mathematically, I can use maybe computer or whatever it may be. Mathematically, I should analyze the construction structure. I should be able to say, okay, this particular flyover can bear this much amount of load in direct loading. So, for all systems, direct loading is not possible. And indirect loading is possible for all systems. Means that what we are going to do in network theory, we will take physical system. We will analyze this physical system. Okay, and this particular thing will be mathematically modeled, which is nothing but network. Okay, so which is nothing but network. So maybe it may have V is directly proportional to I, for example. Maybe we will model this with a resistor. Okay, or we may model this with a inductor or maybe capacitor or sources, or combination of all this, such that once mathematical model is prepared, this is going to be mathematical model. Once the mathematical model is prepared, then I will apply KCL, KVL, mesh, nodal, transients, theorems, whatever it may be. Then mathematically, in the sense on paper, I am going to apply this much voltage and I am going to find how much is the current. Okay, so what is the purpose of network theory? You can make a note of this. Okay, purpose of network theory. What is the purpose of network theory? Means that in order to model electrical physically existing systems mathematically and to get the conclusions. Okay, so purpose of network theory means in order to mathematically model physically existing electrical systems and to analyze one thing. Now, for example, you want to build a new system. In order to build a new system, maybe for example, let us think of filter. Okay, high pass or low pass, anything. For example, you decided to design a filter. For example, okay, so even though you don't know what is meant by capacitance, what is meant by resistance, wait, it will come very soon. I will start from very basic, what is voltage, what is current. I will tell you what is resistance, what is inductance, what is capacitance, what is actually happening inside. Okay, for example, if I keep on increase frequencies here, what will happen? This particular reactance will keep on reduce. So for less frequencies, output signal will be there. For high frequencies, it will become short circuit. For example, infinite frequencies, it will become short circuit. So it is going to be low pass filter. In the sense, low frequency signals can be tapped here. High frequency signals can be stopped. For example, if I have okay, so this is going to be, for example, in this case, if frequencies are less. Okay, sorry, just a minute, let me change this. Okay, so if frequencies are less, reactance is going to be less. Once reactance is less, automatically, for example, frequency of 0, it will become short circuit. BTech guys, don't get tense. I will tell you very soon what is inductance, what is resistance, what is capacitance. Stay tuned. Now, for example, if frequency is less, automatically this reactance will be less. Maximum voltage will come here. Maximum signal will come here. For example, if I increase frequencies, this will become, for example, frequency is infinite. This will become open circuit. Under that condition, signal will not come. So, means at low frequencies only signal will come here. At high frequency signal will not come. Means that it is also low pass filter. Okay. So, conclusion is very simple. Low pass filter can be designed this way or low pass filter can be designed this way. Okay. So, for example, if anybody asks you to design low pass filter, you can choose either this or this. Now, one beautiful interview question for BTech, like campus placements. Okay, they will ask you, why don't we use inductor in VLSI chip? Okay, so in VLSI chip we don't use inductor. Okay, we will use capacitor only. Why? Because you may know or you may not know as of now. Once you will come to know one day. For example, if I take diode, okay, reverse bias the diode. If I reverse bias the diode, that will become capacitor only. For example, if I have diode, Okay, so if I give positive here, it will become short circuit. If I give positive here, it will be open circuit. Okay, so just a open circuit in the sense our capacitor only. What is capacitor? Two conducting plates separated by insulation. Okay, so my diode in opposite direction, like in reverse biased condition, it will behave like a capacitor. So how much space will be required for a diode inside a chip? Okay, it's a VLSI chip. But if you think of inductor in this, I have to take a wire and how to wind the wire. So space requirement will be more for inductor. So from VLSI chip design point of view, we can say we have to use this only. Okay, because this can be implemented in the chip. Okay, VLSI chip, your mobiles and all, we will have no VLSI chip. So anyway, forget about it. Now let us come back to this thing. So design can happen either this way or this way. Okay, but analysis, like physically existing system mapped into mathematical system, this is called as analysis. And for example, for physically existing system, actually network theory is meant for two things. What are those? Physically existing system, you please convert to mathematical model, and that mathematical model analyze by using your network, like KCL, KVL, mesh model, like that, and you will get the solution that is called as analysis. If you want to design new things, that is going to be called as synthesis. In our GATE or ESE exam, or normally in any competitive exams, this will not be there. Why? Because the moment it is synthesis, unique solution will not cut, because low pass filter I can design this way or this way. So the moment it is synthesis, unique solution you will not get. You will get one solution, your friend will get one more solution. But if you think of analysis, for a given supply voltage, how much will be the current, each and every one of us should have the same answer. So in order to give ABCD options, okay, compulsorily they have to give analysis only. Okay, and if you think of synthesis, yes, unique solution you will not get, so they can give only in descriptive. Here also some forms will be there, Foster form, Kaur form and all will be there. And in BTech, I don't think in any of the college it is there. And in ESE syllabus, long back we used to have synthesis, but now synthesis is not there. So only one thing, what is that? Conclusion is network analysis plus network synthesis is nothing but network theory. Analysis, unique solution. You may use mesh analysis, your friend may use nodal analysis, but both will get the same answer. That is analysis. Synthesis, we don't have any syllabus. To develop any new system, again we need network theory. So from now onwards, we are not going to discuss about this. We are going to discuss about network theory. Network theory will become network analysis now. Network analysis now. Now, in network analysis, what are the main boundaries? Basically, we should be like Arjuna, not like Abhimanyu. Means that when to enter we should know, when to come out also we should know. In network analysis, when to enter we will come to know, but boundary should be known. When to come out also we should know. When network theory should not be used, we should know now. When network theory should be used, we should know. So boundaries are very important. Boundaries means that my network analysis or network theory is meant for linear, lumped, finite, passive, bilateral, causal, time invariant systems. My network theory is meant for these only. Means that you can write it linear, lumped, finite, passive, bilateral, causal, time invariant systems. Now let us see what are these qualities means. When it will become a linear, when it will become lumped and all, let us see each and every one. First thing is linear. What is meant by linear? For example, if I have this is going to be y, this is going to be x. Okay, if you basically mathematical, a physically existing system has to be converted into network by using our properties, and after that everything is going to mathematics. So for example, if it is with 45 degrees means that y equal to x. For example, if I have x value of this much, y value will be this much. Now for example, if I double the x, y value will be doubled. So this principle is called as homogeneity. So by principle of homogeneity, if input is increased by k times, output also should be increased by k times. That is linearity. Okay, so about superposition we will discuss later. Linear means that if input is increased by some k times, output also should be increased by k times. That is linearity. And in our network theory, though we don't know as of now what is meant by voltage, what is meant by current, very soon we will come to know. So in network theory, linearity is defined between voltage and current. If current is increased by k times, voltage also should be increased by k times. Such a property is called as linear. Now let me think of our physically existing systems. I am saying network theory is meant for linear only. Okay, but what about our physically existing system? For example, let us think of our generator. Okay, in our generator, this is going to be current. For example, this is going to be some generator. What is this? DC generator, AC generator? We will come to know later. It's some generator or battery. Okay, so for example, this is generator. And for this generator, if I keep on increase the load, in the sense if I keep on increase the load current, this is terminal voltage. Terminal voltage is going to reduce, for example. Thus, that reduction is going to be like this, non-linear. So all physically existing systems are non-linear. Means that V is directly proportional, I and all will not be accepted in physically existing systems. But in network theory, we are discussing about only linear, only Y. For example, we have network theory or electrical circuits in our second year. In any college, most of the colleges, in second year, student will not come to know what is meant by non-linearity. For example, if you basically one thing we have to understand, in second year you are a kid who don't know what is meant by boundaries much. So under that conditions, they will give you linear system. And linear system, if you come to know how to solve the problems, how to write equations, for non-linearity will come in masters. In non-linearity, you please analyze in masters. Physically existing system is non-linear only. So, though it is non-linear, you are going to learn about non-linearity in third year in machines a bit. And after final year in masters, you are going to master non-linearity. How to solve non-linear equations, numerical methods is there, some computer programs will be there, algorithms will be there, everything will be there. So, I can say one thing here. Okay, though it is non-linear, what I do is, for example, from here to here. If my generator operation is between this current and this current only, in the sense generator minimum current is this much, maximum current is this much. So when my generator operation is in between these two regions only, I will assume this as a straight line. This is called as linearizing effects of non-linearity. So when the operating region is very less, we are going to assume it as straight line. Straight line means that linear. Now you cannot apply network theory from here to here, because from here to here if I take, for example, this is full load current. Okay, maximum current, full load current. So for example, if I want to operate from no load to full load, what will happen? No load to full load, my black is going to be the original one. And approximated by network theory is going to be no load to full load. No load to full load is going to be straight line. So what is the error you are getting? More. Means that, for example, a physically existing system is there. Physically existing system is exactly loaded, for example. Now that particular loaded condition of physically existing system, we are going to write mathematical equations. Now by mathematical equations, you are going to get some conclusion on the paper. So physically existing system, your network, paper. So if physically existing system is giving, for example, 100 volts, your maths also should give nearer to 100 volts. Means that error should be less. But here, if I consider from no load to full load, error is going to be more or not between red and black. But if I consider only from minimum to maximum, error is going to be less. So in the linear region only we are going to analyze. Though we know our systems are non-linear. Okay. Now let us think of lumped. Okay, what is meant by lumped? Now, a beautiful concept here, don't miss, beautiful, really beautiful concept. For example, I have one physically existing system. I have one physically existing system. What is this length? For example, 1 meter. 1 meter. Now, if I am giving some input signal here, output signal will come here. This is going to be output, this is going to be input. Okay, so input is going to be this much, output is coming. Now, once you hit your input signal here, after some time of delay, output will come. What do you say? Because my electromagnetic signal has to travel from here to here. No? Okay, my electromagnetic signal has to travel from here to here. So while traveling from here to here, if you are losing some information, we have to go with distributed parameter. If you are not losing much information, we can go with lumped parameter model. Let us analyze that. For example, what is wavelength lambda equal to velocity by frequency? Meters. Because velocity of electromagnetic wave is in meters per second. Divided by frequency is cycles per second. So second meter. Okay, so lambda is called as wavelength. For example, what is velocity of electromagnetic wave? Velocity of electromagnetic wave is 3 into 10 to the power of 8 meters per second. Okay, focus here, all of you, please. Now 3 into 10 to the power of 8 meters per second divided by, for example, this operating frequency. If this operating frequency is, for example, 3 Hz, just 3 Hz. Okay, frequency is 3 Hz. What is a lambda wavelength? Wavelength is going to be 10 to the power of 8 meters. Okay, of course, you did not understand yet. You will understand now. For example, in the second case, also lambda 2 is going to be 3 into 10 to the power of 8. For example, if frequency is 300 megahertz. 300 megahertz, just as an example, then what will happen? This is going to be 1 meter. Again, you did not understand. Wait. For example, if operating frequency of the input signal, for example, if the frequency is 300 gigahertz or 3 gigahertz, whatever it may, we will see. For example, 3 into 10 to the power of 8 light velocity divided by, it is 300 gigahertz. 300 gigahertz. Then what will happen? 300 10 to the power of 8, 10 to the power of 8 will get cancelled. So one more 10 will come and 1000 will come. So 1 by 1000 meters or 1 millimeter. Now let us compare. For example, let us go from here to here. Okay, my wave will travel here. Okay, per cycle. See here, seconds will got cancelled. Meters per cycle is the wavelength. Meters per cycle. So, for example, in this case, just to travel 1 mm, 1 cycle is consumed. So, for example, in order to travel for 1 mm. So, in order to travel for 1 millimeter, 1 cycle is consumed here. Okay, so in order to travel 1 meter, 10 to the power of 3 cycles are required. So if I hit with some signal here, after 10 to the power of 3 cycles, output will come. Okay, for example, it means, let me write here, 10 to the power of 3 cycles are required. Okay, in this case, for example, if input frequency is 300 megahertz, under that condition, 1 meter per cycle, lambda is velocity by frequency, meters per cycle, 1 meters per cycle. So in 1 meter means my wave will travel from here to here and it will lose 1 cycle. For example, 3 Hz. So 3 Hz in the sense 10 to the power of 8 meters. Means that this is going to be 10 to the power of 8 meters. Means that 10 to the power of 5 kilometers. 1 lakh kilometers. So by the completion of 1 cycle, it will go, my wave will go till 1000, means 1 lakh kilometers. For example, you are giving some information signal here. Information, not power, information. So for example, you are giving information here and you are expecting information output. For example, if the operating frequency here, so the moment you give information here, after 10 to the power of 3 cycles, output will come. If you think of here, means it is 1 by 10 to the power of 8. Okay, so point here is, means in this case 1 kilocycles of information you are going to lose if you don't consider wave travel. But here means by the time of one cycle 1 lakh kilometers will travel. So in order to travel 1 meter, how much information you are going to lose? You are not going to lose any information. So logic is very simple here. What is that? For high frequencies, for the same 1 meter only, for the high frequencies, very high frequency of 300 gigahertz, compulsorily wave travel has to be considered or analyzed. Because if you want to have that particular 10 to the power of 3 cycles, during that 10 to the power of 3 cycles, what is happening inside the system? Okay, in order to know what is happening inside the system during 10 to the power of 3 cycles, you have to consider wave travel. For example, if operating frequency is very less, under that condition, I am not going to lose any information. So, under less frequency conditions, what I can say, the moment I hit the signal, immediately signal came out. Means that velocity of electromagnetic wave can be assumed as infinite if frequency is less. Or directly we can say, just compare this lambda with length of the element. Length in the sense length or breadth or width, whatever may be is maximum. Okay, in between length, breadth, width, whatever may be maximum, we are going to consider that. Now, for example, if lambda is very, very high, compared to length of the element, what is happening then? You are not going to lose any information. Under that condition, we are not losing any information, much information. Under that condition, instantaneously we can say the moment my electromagnetic wave hit here, immediately at the same instant it came. Means that velocity of electromagnetic wave is assumed infinite. This is called as lumped. So in network theory, velocity of electromagnetic wave is not going to be considered. For example, same system, if you go with very high frequencies of communications and all, then we should not go with this lumped parameter model. We have to go with distributed parameter model because it is taking much, not time, cycles. Okay, so very simple. What is that? Network theory is meant for lumped parameter. Okay, so linearity, lumped, and students, you please write this. If lambda is very, very high, wavelength is very, very high compared to length of the system, length in the sense maximum value between length, breadth and width. So if it is there, we can assume it as lumped. Means that in lumped parameter model, for example, I have one switch here, one system here. If I switch on, maybe incandescent lamp. Okay, so if I switch on, incandescent lamp glow. Okay, so we can do in two ways. For example, if I switch on here, my wave will travel from here to here in order to glow the lamp. Network theory. In network theory, what I do, like the moment I switch on, instantaneously it will come. The moment I switch on, instantaneously it will glow. Network theory means lumped parameter model. For example, once you switch on, it is taking much time. For example, our power system is there. Power system transmission line is there. Long transmission line is there. Okay, so in the long transmission line, if I switch on here, after some cycles of delay only output will come. So in long transmission lines, we cannot model that with lumped. We have to go with the distributed parameter model. Means that traveling wave. Okay, so traveling wave concept will come when this and this can be, this and this can be compared. But if it is uncomparable, it will become network theory. So conclusion is, in network theory, velocity of electromagnetic wave is assumed to be infinite because we are considering lumped model. Okay, after that, finite. Beautiful question, beautiful interview question. In IIT Delhi, they will ask actually. So what is meant by finite? What is meant by finite? What is meant by finite? Means that boundaries of the system should be finite. Okay, boundaries of the system should be finite. Now you may think, sir, we have generator. Boundaries are fixed, no? Maybe generator of this much size, or this much size, or that much size. Maybe motor, boundaries are fixed. Maybe electrical lamp, boundaries are fixed. Boundaries in the sense spatial representation. Okay, so means everything is finite only, no? All electrical systems are finite. Is it finite? No. Basically, if all electrical systems are finite, why to define finite here? No, why to getting my point, right? So we are defining finite means that there should be infinite system. Now you will understand. What is infinite system? Means that boundaries of that particular system should be infinite, but electrical properties of that you should be able to utilize. So infinite system cannot be modeled or analyzed with network theory. Now can you tell me example of infinite system? Because if you can think in this way, automatically you need not remember anything. Okay, so what is example of infinite system? Infinite system, ionosphere. Okay, so ionosphere compared to our earth, ionosphere is big. Okay, but electrical property of ionosphere, because it will reflect the waves and all, so in radio transmission, okay, means in radio transmission, signal transmission, we will use ionosphere electrical properties. In the sense, signal will be hit and after that it will be reflected to some other place. So we are utilizing electrical properties of ionosphere. Maybe let me write here ionosphere. Okay, so means ionosphere is very big for us, infinite for us, but electrical properties of ionosphere is being utilized in transmitting radio waves. What does it mean? Means this is infinite, this is finite, means that finite systems only can be analyzed in network theory. Now basically in NIT Delhi they will ask you what is the example of infinite system, because finite means that infinite should be there, otherwise why should I define finite? Forget about it. Now let us think of passive. Okay, about active, passive or complete passive. For example, means let me tell you just like that, and again we will discuss this in Telegnan's theorem. Anyway, in a network or in a system, conservation of power, that's it. So power delivered equal to power absorbed. Conservation of power. Power can neither be destroyed nor delivered. Okay, power can be transformed from one form to another form. We have seen that in our 8th standard. Okay, so conservation of power is nothing but passive. It is not active passive elements. We will discuss in Telegnan's theorem. Forget about it. Now what is bilateral? Basically basically network analysis is meant for this only. Let us think of what is bilateral. Bilateral means that for example, I have some system. If I give some input here, output will come. Okay, for example, if I give same input here, if I give at the output side, same output I should get at input side. That is called as bilateral. Means normally in our network way, I can say that input is nothing but excitation, and output is nothing but response. Okay, we can say that if you excite here, response will come here. If you excite here, response will come here. Here also one beautiful interview question is there. Okay, so ratio of excitation to response, in the sense input divided by output, or transfer function. Okay, so for example, ratio of response to excitation, output by input is transfer function only, no? So transfer function is invariant, is nothing but bilateral. Means that ratio of response to excitation is invariant even if you interchange excitation to response. That is bilateral. Now the question here is capacitor. Is it unilateral or bilateral? In physical world, can be unilateral, can be bilateral, because we have our power electronics. In power electronics, in some areas, like you can go to your lab, power electronics lab, and check. So on power electronics, some of the capacitors plus minus signs are engraved. Okay, so why plus minus signs are engraved even when it is bilateral? No, it is called as polarized capacitor. Don't do reverse way, right? So plus should be connected to plus only, minus should be connected to minus only. That is called as polarized capacitor. If you interchange the connections, it will burst, it will get damaged. So don't think that all capacitors are bilateral, but our network theory capacitors are bilateral. Means that whatever may be the system which is bilateral, such system only we are going to analyze in network theory. Okay, so don't think that in that case power electronics, maybe that capacitor is unilateral. No sir, how to analyze with network theory? Who is asking you to analyze with network theory? Because network theory is meant for bilateral only. If any physical thing is non-bilateral or unilateral, we cannot analyze with network theory because boundaries are fixed. Why? Because boundaries, you are an engineering student at second year. So the moment you are in second year, directly non-linearity, physically existing, everything cannot be discussed. Already many people are confused with network theory. Anyway, so this is bilateral is over. What is causal? Okay, so what is causal? About causal, signals and systems faculty deal in depth, like causal, acausal, anti-causal, many things he will discuss. But anyway, let me tell you only one statement. What is that? If means output we are going to get after giving input only, not before giving input. Okay, so causal means output should come after input is given, not before that. More about that signals. Now let us think of again time invariance. Beautiful thing. Okay, so what is time invariance? Let us see. In time invariance means that independent of time. For example, my machines lab rheostat is there. Right? In our machines lab rheostat will be there. We will do like this. So in machines lab rheostat, what will be there? Maybe nichrome wire. We will use high resistance wire. Forget about all high resistance wire we are going to use. Now that particular wire is exposed to at least oxygen air. So because of oxidation of that particular wire element, wire material with the oxygen, because of oxidation, my resistance value of your physically existing rheostat will increase. For example, as of now 100 ohms can be there. After 5 years if you measure, because of oxidation, it will increase to, for example, 105 ohms, 105 ohms. Okay, as of now 100 ohms, after 5 years 105 ohms, but such variation we are not going to consider in network theory. Okay, now let me tell you a beautiful thing. Basically many people feel that time invariance is defined for any time. No, bilkul no. Because for example, let us think of 100 ohms rheostat is there. After 5 years that value became 100.5 ohms. So in 5 years, what is the variation? 5 ohms. In 1 year, how much will be the variation? Will be there. In 1 month, 1 day, 1 hour, 1 second per cycle. So point here is time invariance is defined per cycle. I repeat, time invariance is defined per cycle. So in 5 years it will change. In 1 year it will change. In day it will change. In hour it will change. In second it will change. How many cycles will be there in per second? For example, our power frequency 50 Hz. So 50 cycles will be there per second. So per cycle how much is the time? 20 milliseconds. Okay, so 1 by 50, that's it. So 20 milliseconds. In 20 milliseconds, for example, at starting this is 100 ohms. After 20 milliseconds also we are going to assume that as, yes. So after 20 just a minute here. For example, resistance value is 100 ohms. So after 20 milliseconds also it will be 100 ohms only. This is nothing but time invariance. Now let us see in our next session about elements and all.